Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back to my course on Circular Economy for Sustainable Buildings. In the last class, we saw some aspects of energy management. We will continue with the other aspects of energy management which I had already introduced it to you in the previous class. So, in this class, we will see what are the current energy management methods, and in that what are the government policies and energy standards in terms of energy efficiency from 2001 to present. What are the government policies and energy standards with respect to energy meters and their role? What do you mean by energy efficiency in building sector, and what are the future prospects? This is what we will see today. So, if you look at energy, the current energy management methods and the government policies and energy standards, that has undergone a lot of transformation. In the year 2000, for the first time, the Energy Conservation Bill was introduced in the Lok Sabha, and a very important act called as Energy Conservation Act came into place in 2001. By virtue of that, the Bureau of Energy Efficiency, also known as BEE, was formed in the year 2002. Then came the Standards and Labeling Scheme in the year 2006. Something of real importance to architects, which is the ECBC, came up in the year 2007. And then we had a number of schemes come up, such as the Bachat Lamp Yojana in 2009. We had the Ujala SLNP in 2015. Then a very important thing that has come up in the ECBC in the residential sector and State Energy Efficiency Index in 2018. The National Cooling Action Plan currently has gained a lot of momentum but was established in the year 2019. Then came the Energy Conservation Amendment Act in 2022. Of course, there were other things like Roshni, Unnati, which came in 2019 and 2021, and so on. And this is an ongoing process. So, the government of India has done a lot of work on energy conservation. Chief among them, which I have already shown to you, which is the ECBC or Energy Conservation Building Code. Then you also have the Energy Auditor or Energy Management Examination of the BEE. So, this EMEA is the Energy Management Energy Audit Exam of the Bureau of Energy Efficiency, which came immediately after 2002, which was in 2004. Then the agriculture demand side management. This offers a very unique way to influence and change the equipment buying habits of the end users and so on. And of course, the National Action Plan for Climate Change, NAPCC, that is also a very important thing that has been brought up by the Government of India's program in the year 2008. So, in 2008, that has come up where we started looking at what are the ways of conserving energy, and then we moved towards the CFL scheme. CFL is the lighting So, in 2008, to mitigate and adapt to the adverse impact of climate change through NAPCC, the many other schemes came into place, like the Bachat Lamp Yojana, or the which is a CDM based CFL scheme, as an innovative scheme to put in place the central government's initiative to enhance lighting efficiency in the Indian household sector by making compact fluorescent lamps CFLs available at prices which are comparable to incandescent lamps which were used until then. So, lot of such schemes came up. So, this 2009 in which CFLs were introduced instead of the incandescent lamps was a major shift towards energy efficiency. Let us look at the other government policies and energy standards which we have seen in the previous slide, and the important ones I have picked up so that we can understand what they are. First, let us look at the Bureau of Energy Efficiency star rating. The BEE, or Bureau of Energy Efficiency, is a very important scheme where it gave star rating for appliances indicating their energy efficiency, with 5-star being the most efficient. The appliances which are covered under these are air conditioners, refrigerators, ceiling fans, washing machines, LED lamps, geysers, etc. This is implemented by Bureau of Energy Efficiency. The implementing authority is Bureau of Energy Efficiency. Then came the ECBC code. The ECBC code establishes minimum energy performance standards for commercial buildings. This was applicable for commercial buildings, and this was implemented by Bureau of Energy Efficiency. After this, another important scheme is the Standards and Labeling Program, S&L program. This provides energy efficiency labels for appliances to help consumers make informed choices. Over 26 products including refrigerators, air conditioners, electric motors and transformers are the appliances covered under this scheme. Again, this is monitored by Bureau of Energy Efficiency. The Griha rating system, which is an indigenous Indian rating system for green buildings, which is the acronym for Green Rating for Integrated Habitat Assessment, gave a rating system that evaluates a building's environmental performance over its life cycle. Griha was, when it came, applicable to commercial and residential buildings, though today it is widely covered in other typologies also. Griha Council was the implementing authority. The Energy Efficiency Services, which is the EESL, this provides energy efficient solutions and appliances at lower cost through large scale bulk procurement. Under this, the LED bulbs for the Ujala scheme, electric vehicles and street lighting were covered. The Energy Efficiency Services Limited was the implementing authority for the same. The Ujala scheme, which is Unnat Jyoti by Affordable LEDs for All, was a nationwide program to promote energy efficient lighting by distributing LED bulbs at affordable prices. This covered appliances such as LED bulbs, tube lights and fans, and the implementing authority was the Ministry of Power, Bureau of Energy Efficiency and Energy Efficiency Services Limited. The Performance, Achieve and Trade PAT scheme is a market-based mechanism to enhance energy efficiency in large industries by setting targets and trading energy saving certificates. The uh, the appliances or industries covered under this are energy intensive industries like cement, iron, steel, textiles, etc. And this is governed by Bureau of Energy Efficiency. While the Solar Energy Corporation of India, SECI, promotes the development of solar energy and renewable energy projects in India. It covers solar power projects and related technologies, which is implemented by MNRE, Ministry of New and Renewable Energy. The Eco Mark scheme is an important voluntarily eco-labeling scheme for products that meet certain environmental standards. Multiple product categories including paint, appliances, etc. are covered under it, and this is implemented by the Ministry of Environment, Forest and Climate Change. And then we have the NAPCC, National Action Plan on Climate Change, which is a comprehensive strategy addressing climate change and promoting renewable energy and energy efficiency. The sectors covered under this are varied, including energy, water and agriculture, and Government of India implements this policy. Thus, we have several government policies and energy standards, out of which we will see a few, couple of them. The Energy Conservation Act 2001, which is an important act for architects and also for India in terms of energy management. So, the Government of India enacted this Energy Conservation Act in the year 2001, and then it became effective from March 2001. The establishment of BEE, which is the earlier Energy Management Center, it provides very important legal framework, okay, and gives an institutional arrangement to energy management. The enforcement happens at state level as well as central government level. Then the establishment of BEE and state designated agencies come under Energy Conservation Act. It covers buildings under Energy Conservation Building Code. It covers appliances under Minimum Energy Performance Standard, takes care of capacity building by having energy professionals such as auditors and managers, as I said, EA and EM. And then this promotes research and development and innovating financing in the domain of energy efficient products. Then we have the power of state government, which enforces this and levies heavy penalties if not followed, and then gives a lot of encouragement and promotion if you are able to take this forward. The Energy Conservation Act of 2001 was amended in the year 2022, under which enhanced scope for Energy Conservation Building Code included sustainability features. There was also formulation of carbon credit trading scheme. It included transport for minimum energy performance standard. Also, hydrogen, renewable energy, non-fossil source usage also had norms included, and it overall helped in strengthening of state electricity regulatory commissions. So, the Energy Conservation Act 2001 with its amendment in 2022 is a very important energy management method that Government of India has taken. Then comes the government policies and standards which comprehensively, if I put as the activities of if I comprehensively put as activities of BEE, this pertains to creating awareness. Now, this image actually shows India's concern also to concern and commitment to energy efficiency. So, energy efficiency and savings by the Bureau of Energy Efficiency could grow by 15% to even 75% if we start having mandatory audits. Okay, and also star labeling for efficiency, which I will take up in greater detail. So, if you look at the activities of BEC, if you look at the activities of Bureau of Energy Efficiency, they create a number of awareness programs on energy efficiency in the form of general awareness, energy conservation award, painting competition, etc. They are linked to National Mission for Enhanced Energy Efficiency, which has the Perform, Achieve and Trade PAT Act, the Market Transformation for Energy Efficiency, Framework for Energy Efficiency Economic Development, and Energy Efficiency Financing Platform. The important segment which concerns architects and developers and builders more is the buildings energy efficiency through BEE, which is the ECBC for commercial building, ECBC for residential building, and star labeling of buildings. Of course, a lot of emphasis is given towards equipment and appliances, which we will see separately as a class in greater detail concerning standards and labeling. For the transportation sector, with concerns of fuel efficiency and EV vehicles are also considered under the Government of India. Then we have demand side management of agriculture, municipal and energy efficiencies in small scale industries, capacity buildings, etc. Then strengthening of institutional capacity of partners by strengthening the state designated agencies, because there is no point in central government sitting in one place and giving rules without including the state agencies. So, they also strengthen the institutional capacity of partners which are primarily state agency, and also international cooperation in the form of giving loans, financing, and trying to incorporate their learnings and so on. Then we have the Government of India policies and energy standards. See, the compliance with these regulations will ensure that the organization will continue to improve energy efficiency by adopting the best practices and technologies that reduce energy consumption. It can reduce our carbon footprint through the implementation of energy saving measures. So, first is energy efficiency. Second is reduction in carbon footprint. Then enhanced transparency. So, enhanced transparency means by reporting the energy performance and carbon emission in a standardized manner, which can look at accountability and scope for continuous improvement. And then meeting the net zero goals. So, India has set a very ambitious target of going net zero by 2070, And this can only happen if we start accelerating the adoption of sustainable energy practices. So, if you look at countries which have pledged to go towards net zero, we can see that few countries plan to go net zero in 2030, whereas by 2050, many countries plan to go net zero. And then if you see, India plans to go net zero by the year 2070 only, whereas Bhutan is one of the few countries which plans to go net zero in 2030, but they have actually achieved it. And if you actually see countries which have declared themselves as net zero and achieved it, those are Gabon, we have Benin, Liberia, the Madagascar, Bhutan and Cambodia. These countries, of course, we have the Guyana, Suriname. All these countries have achieved net zero targets already. So, India has set this ambitious target to achieve net zero by 2070, accelerating the adoption of sustainable energy practices. How can that be? That is by investing in renewable energy, then implementing energy efficiency measures, which is what we had been seeing, and then engaging in carbon offset projects and monitoring and maintaining diesel generators. Now, if you look at what India has done to manage its energy in the building sector specifically, because all that I told you before was other sectors and also building sectors. Now, if you look at building sectors exclusively, India has, as we already discussed, seen the ECBC Energy Conservation Building Code for commercial buildings in the year 2017. Then we had star rating of commercial buildings. There is support for demonstration projects on energy efficiency. Then there is Eco Nivas Samhita for residential building energy conservation, which came in 2018, and a lot of capacity building is happening in this sector with the state agencies. Then the building materials directory is coming up, and then more than 2600 replicable building design and compliance tool which will enhance energy efficiency is being brought out. Okay, so much of energy management method is done, but in all this I had been going on telling the role of monitoring how much energy is being used. And in that context, today we will venture into one of the first appliances which can help us do that, and that is the energy meter, and we will see what its role is. Energy meter is actually a device or a contraption which can measure and monitor electrical energy consumption of a building. So, there are various types of energy meters. We have the electromechanical meter which measures energy consumption using a rotating disc proportional to the usage of power. This can be used in households or older commercial establishments. Then we have the digital energy meter which measures energy consumption electronically, and it will display the data on a digital screen. Again, this is useful in the residential and commercial buildings for more accurate energy usage tracking. Then we have the smart meters, which is an advanced digital meter that records consumption in real time and communicates data to the utility. These are used in smart grids in homes and businesses to enable real-time monitoring and two-way communication. Then we have the prepaid energy meter. This allows users to pay for energy in advance, monitoring the usage as per prepaid balance, like a phone balance. So, this can be used in residential and commercial consumers who prefer a prepaid billing system. Then there is a net meter. This measures the difference between energy consumed and energy generated by renewable sources such as solar or wind. This can be used in homes and buildings which already have energy installation from renewable sources like solar energy or wind energy. Then we have the time of use TOU meter, which charges based on the time of day when energy is consumed, promoting off-peak usage. This can be used in residential and commercial buildings to reduce the cost during off-peak hours. Then we have demand meter. This measures peak demand over specific intervals and it helps to assess peak load requirements. This can be used in industrial and commercial areas to manage energy use and avoid peak demand penalties. Then there is a bidirectional meter. This measures energy flow in two directions. Energy is drawn from the grid and energy is sent back from renewable sources. So, renewable energy systems like solar or wind power installation for grid tied systems can use this. Then we have what is called as a multifunction meter, which records various parameters such as voltage, current, power factor and energy. This is useful in commercial and industrial settings and utility companies to monitor multiple energy characteristics. Then we have what is called as a sub-meter. This measures energy consumption of a specific section or equipment within a larger system. So, this can be used in large residential buildings, industrial units or campuses for monitoring specific usage areas. So, if we look at energy meters, there are various types of energy meters available which fulfill various functions. From this list of 10 energy meters, one can choose the appropriate one based on the application they have. Now, let us see what are the ways of strategic planning for energy management and what are the low cost energy efficiency measures architect can take or choose. For strategic planning for energy management, energy audit is a very important component. We have already discussed that. One needs to set objectives of how much is the target of energy. We should get technologically upgraded. For example, we had the incandescent light, we shifted to CFL and now we talk only of LEDs. Then there should be good employee engagement because it is very important to create awareness in stakeholders. Therefore, if you see in every act, capacity building is an important component. We should strive to use renewable energy sources and monitor and report with transparency what is the energy consumption energy consumption pattern in the building. We should always understand there is continuous scope for improvement when it comes to managing energy consumption. Let us now look at what are the low cost energy efficient measures that one can follow as an architect. First is shift completely to LED lighting, which has already happened. Next is go for smart thermostats which can control the energy consumption based on the settings that you use in the thermostats. Go for Energy Star appliances. I'll get into the details of it later. Have what is called as power strips and go for water saving fixtures. Insulate your building as much as possible if you live in a very cold climate. If you live in a very warm climate, then try to design your building in a climate sensitive manner. Go for window treatments so that if you have air conditioned buildings, you don't lose too much of energy because of infiltration. Go for regular maintenance of your building, whether it is for insulation or whether it is for heat proofing or whatever it is, and get into behavioral changes. Simplest behavioral changes to switch off the light when someone exits the room. So these measures will definitely end up with low cost energy in buildings. Then what should be done for monitoring and maintaining energy savings? First is implement automated energy management systems. So when you automate it, you already have the numbers and you will get to know things in a transparent manner. Conduct regular energy audits and find loopholes where leakage is happening. Go for employee engagement programs, which is basically capacity building. Always maintain your appliances with a proper maintenance schedule. Have performance benchmarking. What is the extent to which you want to be energy efficient? Have a benchmark and approach it. Invest in renewable energy sources because that makes sense, because over a period of time renewable energy sources are the go-to, because non-renewable energy sources would become dip. Have a proper feedback mechanism of whatever no whatever policies you are imposing on people. Get a feedback for it. Work as a circle and go to employee engagement programs if the employee is not convinced, and so on. So what is the future of this? If we have already done so much, what are the future prospects? To understand that, we should also understand what are the challenges to achieve energy efficiency, especially in the cost and technological gaps. So the future trends in energy efficiency technologies will have global initiatives to promote energy efficiency. So we will have things like the Paris Agreement or sustainability development goals to meet with. So energy efficiency stands as a pivotal component in the modern narrative of sustainable development, because this is linked to many other aspects like GHG emissions or climate change and so on. So it is not just a cost saving mechanism, but it is we should have a fundamental shift in how we consume energy and how we conserve energy. What is the effort we are putting towards it? As we look towards the future, the trends in energy efficiency are shaping up to be very innovative and also transformative, because this is driven by technological advancement. We also have simultaneous policy changes happening, and there is a growing collective consciousness about environmental impact, which is a great thing and which is a great shift in our mindset. So from the integration of smart technology in homes and industries to the adoption of energy standards and certification, the trajectory is clear, which is doing more with less, and that is what we should actually be doing. And if we actually start splitting our future prospects, then the first would be a smart technological integration. So this can be done with latest technologies like IoT devices or smart home systems, which are actually revolutionizing energy management. For example, I already told you the example of a thermostat. How we can learn the user's preference and adjust the cooling system, the AC system, to optimize energy use, which can lead to a significant reduction in energy consumption. Second is the renewable energy synergy. So, solar panels which can be paired with energy efficient equipments or appliances, this can ensure that we are able to generate energy in a green manner and also use it more effectively because of the energy efficient appliance which we are attaching to the renewable energy source. Third is energy storage innovations. Now we have batteries which can store solar energy during peak production times so that we can use it during lower production periods. So it is crucial to maintain a consistent energy efficiency, but the design of the battery needs to undergo dramatic transformation in terms of its sustainability. The fourth one is green building practice. So, green building practices involve design of buildings which uses more of passive energy, whether it is solar passive energy or whether it is wind energy and so on. We should design the building to be climatically responsive and energy efficient. Then the fifth is policy and regulatory frameworks. So, all over the world, governments are implementing policies that will require us to incentivize energy efficiency. So, we need to promote energy efficiency as well as have policies which will give brownie points or incentives if we follow those protocols. Then there needs to be a dramatic consumer behavior shift. So, this shift in behavior should be with people who choose and opt for energy efficient building design or energy efficient appliances, and that will only actually sustain to reduce our carbon footprint or energy footprint. Seventh is corporate energy strategies. Companies or industries are energy consuming sectors, and these companies should start adopting energy management systems to monitor and reduce energy waste. Actually, it is happening in a big way, but more and more needs to be done on this, because the definition of companies and factories should start expanding. Even smaller ones should start adopting these measures. Then transportation electrification. So, the automobile industry should start shifting towards electric vehicles, which is also happening now. Then we should have decentralized energy systems. So, what will happen is, when you decentralize, it will allow for local and energy efficient distribution to happen with reduced wastages. And then we must never hesitate to use advanced material and technologies. We are not actually hesitant, but we should accelerate this process of using advanced material and technologies. Already we are using a lot of advanced materials and technologies in the form of the source of energy, equipments, accessories, CFL bulbs for example, star rated appliances for example, and so on. So, with this we will stop this segment on energy management, as we have seen all the energy management being adopted at Indian government level or state levels, the policies and so on. With this, I will stop today's class. and we will meet with another topic in the next class. Thank you.